In maintenance, we win or lose on a few basics: asset availability, safe execution, and the cost of keeping equipment running. AI is now being embedded across maintenance in practical ways, not as hype, but as tools that reduce waste, reduce downtime, and speed up decisions. The biggest shift isn't that maintenance suddenly became complex. It's that AI has made some long-standing problems cheap enough to solve now. Modern machine learning and generative AI can work with messy sensor data and unstructured text, so we can tackle trapped value that used to be too manual or too expensive. Not every AI idea is worth pursuing. We focus on opportunities that are measurable and scalable. A simple filter: how big is the value? Can we measure it? Do we have the data and workflow access? And can we scale the solution at a reasonable cost? Here's the practical map of how AI shows up in maintenance today. It's defined by what people actually see in the field. First, data foundation AI. Clean master data and better work order quality, so downstream decisions are reliable. Second, condition monitoring and anomaly detection, spotting early signs that an asset is drifting from normal. Third, predictive and remaining useful life forecasting, estimating when intervention is needed and which assets to prioritize. Fourth, diagnostics and root cause acceleration, connecting symptoms and history to likely failure modes. Fifth, prescriptive decisioning, recommending the next best action based on risk, criticality, and cost. Sixth, planning and MRO optimization, forecasting workload and aligning people, parts, and windows. 7. Visual inspection AI, detecting defects from images or video and feeding findings into work management. And 8. Maintenance copilots, chat or voice assistants grounded in manuals and history to speed up execution and improve documentation. To make this concrete, here are 3 common patterns organizations are implementing right now. 1. AI-assisted data governance, preventing duplicates and improving the quality of parts and equipment records at intake. 2. RUL-driven maintenance strategy, using condition signals to review fixed replacement intervals and forecast future workload with known risk bounds. 3. Execution copilots, giving maintainers and reliability teams faster access to job history, procedures, and today's operational issues, including voice-enabled options for field use. The key is that each pattern is tied to a measurable outcome, not just a demo. Directors expect AI investments to be tracked like any other improvement program. For each capability, we establish a baseline, define adoption measures, and track outcome metrics. Outcomes typically include reduced downtime, reduced maintenance cost, reduced waste and obsolescence, improved planning accuracy, and safer execution. This turns AI from a set of experiments into a managed portfolio of returns. If there's one takeaway from this, AI in maintenance is no longer theoretical. It's already practical, and it scales fastest when engineers share a common language and track value consistently. That's exactly what we're building with Next Gen Maint, a place where reliability engineers can explore practical applications of AI in maintenance and see what's already working in the field. Join us at Next Gen Maint as we continue exploring real-world AI use cases and the technologies shaping modern reliability.